What I'm going to do is I'm just taking some of the important information from the reading material, and we're going to just jot down some notes to have a quick study guide tonight. So the first thing we're going to do, and the first thing that we read about, is the difference between rotation and revolution. You definitely want to know the difference between those two words. So rotation is a spin. Revolution, we'll say spin on axis. And revolution is an orbit around another object. You know, so here's the sun. And revolution is going around another object. And you can even do the moon. The moon revolves around Earth. Anything that goes around something else is revolving. Okay, that's one important thing. You got to know the difference between those two words. Okay, another important, it's not as important, but I do know that this is one of the test questions. When is Earth closest to the sun?
Winter.
Yep. Oh, it's not showing. And then when are we farthest?
Summer.
Yeah, I think on the test they ask the month. Like it'll say, what month are we closest to the sun? So you don't need to know January 4th. You just need to know January, and you need to know that we're farthest in July. And it happens to be July 4th, but you don't need to know the 4th. You just need to know the month.
Is it actually on July 4th?
Yeah? Okay. You also need to know, what is it that keeps Earth going around the sun?
Gravity.
Yeah. All right, thank you. Gravity, because what would happen without gravity?
We would slingshot. Bounce around in space.
We'd go flying off.
Not bounce.
Okay, that's good for that page. If you're following along, we were just taking notes on page 11. Now we'll take some notes on page 14. But are we good with this?
No.
Because I'm going to have to turn the page here. And you know what? I'm going to put this video on Google Classroom. So, you could just watch it tonight. Put you to sleep. Okay. We're going on. So now I'm going to take notes. I'll just jot this down. This was page 11. Now we'll take notes on page 14. And page 14 was all about the curved surface is just like a tilted surface. So here's Earth. Here's the equator. And this would be like no tilt on the equator. It's still blurry. Okay, there we go. So the equator is kind of like no tilt, and the poles, the curve of the Earth is analogous to a tilt. So here's energy in a nice, neat circle. And when that same amount of energy gets spread out at the poles, because the curve of Earth is like the tilting of the index card. So what I want to write is more energy less energy. So that's kind of what page 14 is about. When you get near the poles, energy is spread out, and that's why the poles are colder. Okay. Next, I think we can use this same image So this is page 15, and page 15 was just kind of a continuation on this. So not only are the poles cold because the curvature of the Earth causes the sunlight to spread out just as it would on a tilted card, but there's another reason that the poles can get even colder, and that is what? Tilt. So I think we might have to draw another picture to show tilt. Actually, we'll show tilt on our last image, so this is good for now. Okay, the next thing is page 17. Let's look at the apparent motion of the sun during the equinoxes and solstices. So I want you to draw 4 horizons, and we're going to label them December solstice, March equinox, June solstice, and the September equinox. And we're going to draw the apparent motion of the sun across the sky. This would be east, south, north. These are your cardinal directions, east, south, and north. And so, June. July is when the sun is farthest from us, but the actual solstice is June 22nd or 21st. That's the start of summer. Okay, so the apparent motion of the sun across the sky is very low in December, at its highest in the summer, and then in between for both of the equinoxes. And so the result is you have your longest day, your shortest day in winter, and then you end up with equal day and night on the equinoxes. So I do believe those are questions they might say, during, when does the shortest day occur? It occurs on the December solstice. In the northern hemisphere, when does the longest day occur? It occurs in the June solstice or summer solstice. Okay, we're almost done. We just got one more thing to write down. Okay, I'll go. Yeah, I'm just telling you, just one thing left. We good? Okay. Last thing we're going to do, and this is a very good exercise, we're just going to draw out a diagram of the seasons just like you already did, but the more you draw it, the more it sticks in your head. So start with the sun. And really what we're taking notes on right now is page 18. There's the sun. Now when I draw seasons, I started by just drawing 4 circles on each side of the sun. And those represent Earth. Okay, then I'm going to draw my equator and my rotation axis, and I'm going to make sure they're all orientated the same way on each circle. So okay.
Is it rare that just 4 axes?
Yeah, you just want to make sure they're all orientated the same way. And when you make your initial X's, well, they're not really X, yeah, they're crosses. When you make your initial crosses, just make sure that it's orientated so that the tilt is apparent. Like, there's a reason I didn't draw it like this. I need these to show tilt.
Can't see it.
Yeah, there's a reason we didn't do that. They need to, be tilted. Okay, now after you tilt everything, make sure I like to shade it in. Each one of these Earths has a south and a north. I like to shade in one of the hemispheres just to make it, visually apparent which hemisphere is tilted towards or away. And then we can label these equinox. And now, this is pertaining to the northern hemisphere. How do I know what season this is? You should know, especially since the test is tomorrow. You. Yep, very good. I know that this is winter for us in the northern hemisphere because I can see that my hemisphere is tilted away from the sun. So we will go ahead and label this the winter solstice. And so this must be what? Yeah, because see how we're tilted towards the sun, so this must be the opposite. And now we can figure out fall and spring by just making our arrows. The arrows represent our revolution. Summer goes to what? So we'll call that fall, winter, and then this must be what?
Spring.
And that is how you make a diagram of the seasons. It's the best way to study and understand the seasons. So, study tonight. Just take home your workbook. We pretty much just made little notes for each page. You can reread some stuff tonight, and we will end the hour with the hooch. Nice work. And